maximum likelihood estimator for the parameter P of the binomial distribution, but finite, a binomial distribution B of n comma P, where n is very large but finite, on the basis of sample of size small n. Also find its variance. This is the problem. So now the solution. All of you look in here. Your question is to estimate MLE. To find MLE, that means maximum likelihood estimator. Now, for this, what is the clue given in our problem? Binomial distribution. So, how to frame binomial distribution formulae? Okay. P of x is equal to x is, what is the formula we will write? NCX P power x Q power n minus x. This is the formula. But you look at the question now. The binomial distribution formula is called capital N comma P. So we are going to change the parameter now according to our problem. So how will I change? How will I change? Which is capital N C X. Small p will change to capital P. Parameter is given. Small x. Q is changed to 1 minus capital P. N minus x. Whereas x ranges from 0, 1, 2, 3, x plus small. Oh, sorry, capital, because the value is capital. Now, the next one is, we have to find likelihood estimator. Okay. So, to find MLE, find MLE. What is the formula? The formula is L of, so this is called likelihood estimator function x1, x2, etc. xn, comma capital P. Why did I write capital P? Because your parameter is capital P, which is equal to, we are going to write for n number of terms. Understood? We are going to write for n number of terms. So how will we write? How will we write? Capital N C. X will goes to x1, x2, etc. xn, which is xi. Got it? Where capital P will goes to summation xi, and 1 minus p will goes to summation n minus xi. Clear? Now, what is summation xi? Summation xi is x bar, which is summation xi by n. From here, what is summation xi? N x bar. Got it? Similarly, what is summation n minus xi? Where I is from 1 to n. So, summation I equal to 1 to n, capital N, minus summation I equal to 1 to n, xi. all of you know that the given question, all of you look at the question. The capital N is a sample of size n, small n. Size small n. So how many times it will go? How many times your value will reach us? N times. It will go up to n times. N plus n plus n plus etc. n times. Clear? Now, altogether how many times it will be moving? If you take n outside, 1 plus 1 plus 1 plus etc. 1. Correct? So 1 plus 1 plus 1 plus etc. 1. So this also n times. So if you multiply, what is your answer? N square minus summation x. Got it? So I am going to replace this one. Equation 1 is replaced as the equation 1 I am going to replace in this model because of the parameter. Okay. So how can I write equation 1? How can I write equation 1? Okay, which is L of x1, x2, etc. xn, p equal to. How will you write? Look at now. How will you write? NC xi. NC xi. So NC xi. Got it? Capital B power summation xi is what? Nx bar. Summation xi is Nx bar. 1 minus capital B bar n square minus Nx bar. Okay. So I will write on directly, which is n square minus Nx bar. How we are getting this one? From here, n square minus summation xi, which is n square minus Nx bar. Clear? Take it as equation number 2. Take it as equation number 2. Next, we have to find maximum likelihood. We have to take logarithmic on both sides. Is this okay? Yeah. Taking log on both sides. So log n. We will write simply log n. Okay? Log of full term NC xi P bar Nx bar 1 minus P bar n square minus Nx bar. Now, individually we have to apply log. Okay, so it will be log NC xi first term, because this is under product. So if you input it here, it will be Px bar, Nx bar log P. Nx bar log P plus n square minus Nx bar log 1 minus P. Now ignore this constant. This is constant. ignoring, because when you ignore this constant. Why? Because we will do differentiation. We will do differentiation. So the next one is differentiating with respect to P. So dou by dou P of log n. Differentiating. When you differentiate, the constant term is eliminated. We are differentiate only P term. So nx bar, differentiation of log P is 1 by P. Differentiation of log 1 minus log P is 1 minus P. Okay. So next one is for likelihood estimator, dou by dou P of log 1 minus log L equal to 0. Equal to 0. So nx bar by P plus n square minus nx bar by 1 minus P equal to 0. Now what is the LCM here? The LCM is P into 1 minus P. Cross multiply. Nx bar 1 minus P plus n square minus nx bar into P equal to 0. Now we know that denominator becomes 0. Denominator becomes 0. So numerator should be 0. Got it? Multiply 1 by 1 term inside. Nx bar minus nx bar P plus n square P minus nx bar P equal to 0. Now these two terms is getting cancelled or not? So here we have to do it with respect to P. So you get negative value, minus P, minus 1. Okay, into minus 1. So you will get minus here. So you get minus here. So minus. Here also you get minus. Because we are differentiating with respect to capital P. So this term will become plus. So all this will get cancelled. So you will get it as nx bar plus n square P equal to 0. From here, 1 minute. Here you are getting minus n square, is it? Minus n square. This is minus n square. So nx bar is equal to n square P. Cancel 1 n on both sides. So you will get it as P equal to x bar by n. We got the answer for parameter P. So this is the MLE of parameter capital P. Next, we have to find the variance. P cap. So whenever I write MLE, automatically this P will become P cap. Same meaning only. Of inverse, which the formula is minus E dou square by dou p square of log n. So already we have differentiated dou by dou p. Once again you differentiate, you will get minus e dou by dou p of log n. So once again you differentiate p. Okay, so which is minus e dou by dou p of n x bar by capital P minus n into n minus x bar by 1 minus p. So what will you get it now? Once again we are going to differentiate p only. So you look at here, this is n x bar p bar minus 1. This is n into n minus x bar 1 minus p to the power minus 1. That is the meaning. Got it? Once if you differentiate, this is dou by dou p. So once if you differentiate, what is your answer? N x bar dou by dou p of p inverse. Correct? And minus n into n minus x bar dou by dou p of 1 minus p to the power minus 1. So what will you get it now? Which is minus e n x bar p power minus 1 differentiation is minus 1 p to the power minus 2. What is this differentiation? N into n minus x bar minus 1 minus p to the power minus 2. So we will write down neatly with respect to the formula. So n x bar by p minus p square minus n into n minus x bar by minus 1 minus p square. So you will get it as, so you will get it like this. So which we can rewrite as capital E multiply minus inside n x bar by p square plus n into n minus x bar by 1 minus p square. So here the term will become plus here, but minus is there, so you get minus 1. Multiply E inside. Multiply expectation inside. So, which is n by p square E of x bar minus n into n minus expectation of x bar divided by 1 minus p the whole square. Now if you look at here, we are differentiating with respect to p. So this term will become, look at here. This term will become, we are going with respect to p, so this term will become as minus 1 because we are doing with respect to p. So what will happen? You get the plus term here. So when you bring it down, it will become plus. Now when you multiply minus inside, you get it as plus. And here also, you get the term as plus term. So you know that for binomial distribution, expectation of x is NP. Or instead of x, you can write x bar also. And variance is NPQ. So, substitute the term here. N by p square into NP plus n into n minus NP divided by 1 minus p the whole square. So cancel p here. 1p cancel. Multiply the term here. N square by p plus n square minus n square p by 1 minus p the whole square. Okay. So now taking LCM. We get the answer to be n square by p into 1 minus p. So this is the answer for variance. So this is the solution for the problem.